I think we have most people starting here right now. The session will, of course, be recorded and you'll receive the slides just like the previous times in the morning tomorrow. So let's get started. Welcome to the first session of the summer school. So now we'll actually be diving into Click LCA, how we can actually use it. I'm joined today by a bit more moderators to make sure that if there's any questions regarding the software, that we'll be able to answer them pretty much right away. So we have again, Sean, Antti, and Samantha, our CS team members, or CS team specialists who will be answering the questions. We have two of our business developers, Fernando Barrios, who is our business developer for the Nordics, and we have Vasilis, who is our business developer for North America. And then we also have Veselin, who is our database team manager. So would there be still any data-related questions, he will be able to answer them also. So yeah, good morning, good afternoon, good evening, depending on where you are. Let me close this and I'll hide this floating panel as well. Floating meeting control. And let's start this meeting. So same thing like the last times really. If you have some questions, please put them in the Zoom Q&A function. We cannot see all the questions which are asked in the chat view, but in the Zoom Q&A function, we'll be able to try to answer everything. I hope that the moderators will be able to answer most of the questions throughout the session, but of course, after the training session itself, we'll have some time for that Q&A session like we had yesterday and the day before as well. The recording and the slides, well, the recording will be made available tomorrow. The slide for this session you have already received this morning, and it also actually includes how you can access Click LCA. So just check those slides if you already want to access it, and otherwise you're free to check them, of course, after this session as well. So what do we do in the last session? So the session yesterday was really theory heavy. So we talked about a lot of theory parts, which will basically help you make sure that you understand Click LCA and what you're doing and why you're doing it when we are starting to do building LCA or carbon studies. We started first with the life cycle stages. So we covered the different type of life cycle stages, which will be available in the software. Of course, these depend on the tool you're using, but the tools we have in this summer school license, those are basically the relevant ones we described. After that, we went over the different assessment methods. And in this case, we looked at the characterization methods of CML and Tracy and the different type of impact indicators. In the summer school today, we'll only have CML indicators. So we don't have North America-based tools. But they function very similar, of course, but in North America, there's a bit different type of data available. We talked about some short core building LCA concepts, so just some base information, which will help you also make sure that you get full out of this training. And then we talked a bit more about the data. So what are EPDs, what are program operators, what kind of database structure are we using? And we'll talk a bit more about the data today, of course, also. And also, what kind of data we do integrate and what we, for example, don't integrate. So like yesterday, if you want to discuss the Click LCA summer school, feel free to join our user group. So if you go to LinkedIn and you just search for LCA Made Easy, you'll find that group and one of the moderators will be able to let you in right away. So what will we be discussing today? So we, of course, will start with what do we actually include in the summer school license. So I'll shortly describe the different tools we have, the different features, and what you can access. After that, we'll be talking about the actual software training. So I'll do a live demo of the tools and features which are included in the summer school license. After that, we'll shortly discuss how you can access it. So you can already see it if you check the slides. And then we have, of course, the homework assignment itself. So what do we include here? So since this summer school is kind of talking about how can you do building LCA and carbon studies, we have included two calculation tools for this. So both of these are based on the levels framework. And to an extent, they do pretty much the same. So they have access to the same sets of data, but one only looks at global warming potential. So that's our carbon tool. So this will be a tool you use for carbon studies. And then we have the levels lifecycle assessment. So this tool is a full lifecycle assessment tool made for building LCA, which allows you to access a much wider scope of different indicators. We have also added a building circularity tool. And the building circularity tool does not calculate, for example, global warming potential or anything. It looks at the circularity of the materials which we have used in our assessment. So circularity is becoming quite important. So this is an interesting tool to have on this license also. We'll also have Carbon Designer there, which is one of our early phase baseline tools, but Carbon Designer we'll talk a bit more about in session 6. So I won't cover it too in depth today. If you have the slides, you can also check on these little guidance links. But of course, if you're familiar already with our Help Center, you can also just search for levels there or building circularity or Carbon Designer, and you'll find the relevant articles right away. We have a different mix of features included. So on our Click LCA platform, we have a lot of different type of modules. So we have those 3 modules which are available, which are the levels carbon, the levels lifecycle assessment, and the building circularity. And then we also have a mix of a lot of different features. So not all the features will be as relevant for today. So I've picked all the features which make sense to discuss. So this basically means that we have all the starter and business level features. And this also allows you to do any type of automated import. And then we have a variety of different expert features. So the import options and looking at how we can get data towards Click LCA in a more automated way, that will of course be discussed during session 7 by one of my colleagues, Marios. But I will at least run through one import of an Excel file today, so you can see how this process goes. But more on that will be in session 7. The different type of expert features we will be discussing today are, for example, our green material benchmarks. This allows you to access the entire benchmark set of a specific type of material. So for example, we'll look at concrete for a specific type, let's say ready-mix concrete for external walls. And you'll be able to check right away what is the best one performing in this entire benchmark set. We'll have a bunch of advanced graphs. These will be available on the results pages. So if you go, you have done an assessment or you've already inputted some data and we navigate to the result page later, you'll be able to see a bunch of extra graphs which are not normally there. We have some detailed calculation options in the software, which allows you to kind of see how the software is calculating it. So on the front, Click LCA looks quite straightforward, but of course in the back end, there's a lot of calculations being done, which you don't have to do yourself, which makes LCA a lot faster. So we'll cover that also. We then have a feature which also allows you to compare materials in a bit more advanced way. So you don't have to do entire design setups. You just pick what materials you want to compare and we check them, and that is pretty much it. So that is one feature we'll also discuss. And then we have 2 settings which allow for a bit more adjustability of our results. And that is the localization and the user adjustable end of life settings. So these are 2 quite advanced features, but they allow you to really get most out of what type of data we have here. In regards to the automated import options, we do not provide the BIM software ourselves. But if you, for example, want to try to do an import later during the summer school with Revit, Autodesk does have a free version for educational purpose. What you can, of course, do is import an Excel file, so a bill of materials or anything like this. And I will also provide you with an example Excel file you can upload. So let's just dive deep into right away the software training. So let me just close this and switch. We have here, can you guys confirm that you can see my screen? I think I've shared it correctly, but I just want to make sure. Yeah, okay, perfect. Thank you very much. Then I will hide this again. So how can we access Click LCA? First of all, we can, of course, just go to our website, oneclicklca.com. And on the top right corner, we there have our login screen. Here will allow you to register your account if you don't have that yet. So you can just click there on register user and fill in all the information. I already have an account, so I won't be doing that. So I'll click here on training and I'll log in right away. Just have to wait until we get there. So once we are logged in, probably you don't have a project yet. Of course, if you're already a user of Click LCA, or perhaps you already have a student license, you might already have something, but otherwise you just see some basic demo projects. On the left, we then have some latest information, so maybe some updates we have done, these kind of things. We have an help plugin in the bottom, which allows you to access the help center. So if you, for example, want to find something for what we have for students, you could search there right away. And then we have also the user account information right here. We have a help screen, which allows you to also go to the help center directly or find some other information about updates we have done. And then if you have some licenses, they will be showing up here as well. So now how can we actually access Click LCA? If we click here on start a free trial, we'll see that there are some trial options available and some planetary projects, for example, but we won't choose planetary here. We'll check here, building trial available. So in this setup, normally if you have a license, you'll be able to pick it right away, but just skip that completely. And we go there to enter the license key. So now let me just see if I have copied it. I did it correct. So in the PowerPoint itself, you'll have a license key which you can use to access and activate your summer school license. So I click here on activate license and it finds the correct license. It links it automatically to the summer school. And then we have to set up a couple of mandatory things like the name, the type of our project, and also where the project is located. So I will just do this, Stephen or summer school, Stephen Helsinki. And let's say we go for an office building in this case. And since I'm in Finland, I'll just select Finland here. I'll click on next. There's some optional information which you don't necessarily have to fill in, but if you already have an idea of what you want to calculate, you could already fill in, for example, the floor area or the amount of above ground floors. So maybe I'll set this to 2,500, for example, 6. If you already know some information about the frame type you're going to be working with, so maybe our building is going to have a concrete frame or something like this, we fill that in. And if we are pursuing certifications, we can include that as well. So I'll just click on next there. And now we basically have set up our first project. So the first project is now pretty much empty still. We don't have anything there. We don't have any design phase. And we can also see until how long this project is active. So I can see it's linked to the summer school education license, which is a temporary license only for use throughout this summer school. And there's a bunch of information we could now access if we would want to. Under more actions, we can also modify the name and all these kind of things still. And if we would want to share this with another summer school applicant, maybe you're doing this together with a friend, you can also add each other to each other's projects. Now we have to get started with actually creating a design. So we can actually start some calculations in here. And we can do that by clicking here on the Get Started. We have then the available list of tools. So there are a lot of tools in our software, over 120 different modules, but the ones we'll be discussing today are only these 3. So we have the levels carbon, which I said is according to the levels framework and for carbon footprinting or carbon studies. Then we have our levels lifecycle assessment, which is a full LCA tool. And then we have our building circularity tool, which allows us to access or grade the circularity of our building materials. So I will select all of these and I'll click on next. Now, before we start with the assessment, we have to set up our first design. So this could be our option 1, or this could be our baseline, or however you want to call it really. So let's just name this option 1. I can also give it some extra information, and I could also assign it a stage of construction. So how far ahead is our project going? This doesn't affect the calculation itself, but it affects where it places the design within the project. So in this project, which I had just created, I can make infinite amount of designs. So maybe I want to make different type of options with different materials, or do different type of comparisons for different life cycle stages, different type of calculation periods. Everything is basically possible. I'll just keep this to the concept stage design, and I'll keep all these tools here as well. We then also have a section on the scope. So if we're doing this for a certification point of view, like for the levels framework, there will be certain checks which it tells us, okay, if we do an assessment according to levels, you have to include these and these and these building elements. So that could, in this case, be levels. We have to include the foundation and our substructure. We have to include our structures and enclosure, finishes, external areas, possibly services. So it kind of depends on the scope. We can also give it a project type and a frame type. And the project and frame type, they feed into one of our features called the LCA checker. And the LCA checker gives us some feedback on the plausibility of our LCA results. So this doesn't really come into play until you've kind of finished your assessment or are like close to doing the whole building, and then you can actually compare it. But I'll let this one be new construction, and I'll set it to a concrete frame. So we have the majority of checks there already. I will click on next, which will bring us to the lifecycle assessment parameter setup. So this is a quite important step. And I also covered it slightly yesterday when we talked about, for example, those different end of life methods. The lifecycle assessment parameter setup, it basically dictates a set of calculation rules, which will affect all of the designs within a single project. So if we do 10 designs, they are all affected by whatever we are choosing right now. We can use the default LCA parameters, which basically chooses based on our project location, which settings are most relevant. But we can also review and adjust these. And I'll go into this session now. When we start with these parameters, there is a lot of links we can also follow, which bring us to specific articles. So if you want to know more about a specific section, just click on those links and it will take you right away there. The first section we have here would be our service life of our materials. So we can also see here, it says the service life values for our materials, and it's a mandatory setting. So what this one represents is when our materials are going to be replaced. So any type of materials we will include in our assessment, usually they won't last forever. So depending on the type of material, they'll be replaced at some point. The default setting for this kind of building LCA or carbon studies would be our technical service life. And in this case, it represents how long materials last in good conditions. And in those cases also, the same materials will have the same service life. So if we have multiple layers of concrete, they will have the same service life. If we have different type of elements from steel, they will have the same service life, and so on. We also have a commercial service life setting. And in a commercial service life setting, you would, for example, have hotels or retail buildings where the interiors of our building would perhaps be replaced more often. We also have a product specific service life setting. And in those cases, it actually takes the values from the EPDs. So as you recall yesterday, when we looked at an EPDs, a manufacturer usually also states how long their materials last. So it can also take those values. Product-specific service life is also mandatory for some of the certification schemes. And this includes, for example, the German DGMB, the Dutch MPG, and also the French Energy Carbone and RE 2020. We also have one specific value for the UK, and this is more relevant if we're either doing RICS or GLA assessments. So you can actually take values which make more sense for those. The second one we have is our transportation. So the transportation relates to our A4 emissions. So any type of emissions related to the modes of transport and the distances that the materials we are sourcing for our project are traveling from the factory to where we are actually making our building. We have different type of modes available there, and these very much depend on your project. So if you're trying to follow this along or you're going to be doing this later, just try to make it as accurate as possible for what you're trying to calculate. When I'm doing this assessment for a building in Helsinki, I would use Nordic, and this gives me modes of transportation and default distances. Example there being, if I have concrete, this will come with a concrete mixer truck, let's say of 8 cubic meters in capacity, and this will travel about 60 kilometers. If I would use an Australian setting, it would probably still come with a concrete mixer truck because the mode of transportation is quite often the same, but it would probably transfer or have a much longer transportation distance. These first two, our service life values and our transportation distance, they're only default values, so we can always change them later. But since these kind of values are not often specified in EPDs, it's good to still have some way to actually calculate these kind of life cycle stages. This example, I'll leave it to Nordic, and I'll show you in a bit what it does. Then we have a quite important setting, our materials manufacturing localization method. And this is probably, if you're new to this, something you kind of want to check up again later or maybe read a bit more. So I definitely recommend to click on the C guide here and just check a bit more about what this methodology does. Basically, why we have this methodology is if you're trying to do building LCA study or a carbon study in your country, and you're trying to find only local data, you will very often run into the situation that there just isn't enough local data to do an entire assessment. This is quite a problem in Asia, but for example, if we're in, let's say, Norway or we are in Germany, it's not as much of a problem. So if we're doing a type of study, we want to find as accurately our most representative data for our assessment. And in that case, it could be that, let's say we're trying to find some steel, and the best steel which closest meets our requirements is from one of our neighboring countries. We can then still pick this resource. So if I'm doing a study in Finland, but I'm finding the best resource for what I'm looking at that moment from Sweden, I can just pick that resource, and this specific methodology changes the emissions of that Swedish resource to represent that it's actually manufactured in Finland. So it's a very strong methodology. It's also approved by the BRE. So there is some merit in how we actually calculate this. And we're currently also working on updating this methodology to make it even more accurate. For now, I would just recommend to go with the version 1, and the version 2 will soon become the new default. What we then have is our localization targets. And the target here is automatically selected based on our project location. So in the beginning, I had chosen this project would be in Finland. So I can see it is choosing Finland, and I have the latest energy profile from Finland as well available there. Then what we have is the end of life calculation method. So this section on the end of life calculation method, I've covered a bit more in depth yesterday when we had those different type of scenarios and what kind of data we actually get from there, because end of life data is not always present in our EPDs. If I click on the option here, we can also see that we have 3 options. So we first have that material locked scenario. It currently says that this is the recommended because we are no longer updating this method. So this will not change, which is good for consistency of results. With our material locked scenario, we just have C1 to C4 data. So there is just one group. You cannot really see what is demolition or what is waste transport or what is the processing or the disposal. Those other 2 groups, they're a bit different. So the market scenarios, if we select this option, and it's also the option I will select for this training, we'll have expandable end of life. So that means that we'll have C2, C3, and C4 data. But for our demolition, we have to add a C1 scenario, and I'll cover that in a bit. We can also take data from the EPDs. So if a manufacturer has actually decided, okay, we're going to be reporting different type of end of life scenarios for our product, we can also take those values. But the majority of EPDs, as I said, does not have that kind of data. So I'll take the market scenarios, and I'll have some default setting also for the end of life recovery module. What I said there right now doesn't really matter for this calculation too much, but you can change it to different profiles if you want. Now, if I go up here and I'll save these parameters, it applies these to the entire project. So I'll just save them and I'll wait until it takes me back. I can then go over the parameters, and I can also see input data LCA parameters is now selected with a green checkbox. So now I know that the settings for this project are correct. And now I can actually start to see what kind of things can we do here, what kind of assessments can we do, etc. The 3 tools we have now selected are our levels carbon, our levels lifecycle assessment, and our circularity tool. We can also see the units in which these are measured. So our levels tools are in kilograms CO2 equivalent. And then we have our first design here. But we can, of course, always add new designs. As the tooltip here says also, if you want to compare data, we have to have more than one design. We can add designs in 2 options. We can go to the add a design option right here and just fill in new information and choose a new design. And that gives you a new empty design. What we can also do is go to the existing design option right here and make a copy of this. If we already would have some data in our first design, it actually copies this and we'll have a second design which is identical to our first one. So I will just maybe name this my option 2. It won't have any data at the moment, but it's not a big problem. So now we can see we have 2 design options. At this point, if we're a bit stuck and we're not really sure how we should continue or how we can actually get data there is, of course, a couple ways we can get help. We have the help buttons here, which take us directly to the articles for the tools we are working with. So if I click on this one, it takes me, for example, to the article for levels. And it talks a bit about the framework, how we can do this assessment in Click LCA, and so on. We have on the left also a workflow. There's a generic LCA workflow, and you can basically follow all the steps there to ensure that you have done everything. So it starts with our LCA parameters. We have to make sure those are verified. If we have done it, we can check that box and we know these are complete. We can also add a comment there if we want. So maybe say manually verified for Finland, something like this. So you can do different type of checks to just ensure that you are on the right path and you're doing everything correctly for your assessment. So I'll just save that. Then we have, for example, here the setting of the building area. I haven't done that yet, but if I click on input data, I see that there's the option. So you go through all these different steps to make sure you have done everything. And in the end, you can basically go to the download of your results. So we'll also get there in the end, but we'll just start with step 1 for now. So I'll empty this. The help button in the corner here accesses the entire customer support center. So if you have any questions about standards, about the circularity, about the data, you can always go there. So perhaps I want to find out more about CML. I can click here on CML, and perhaps I go to the impact assessment category and check again, what are the different type of standards and impact assessment we have used there. So you can find that all quite easily. On the top, as we said, we have also the help center directly. So if we go there, it just gives us a link directly to the help center, and we can search for all the articles we have there. So I'll close that. So now let's take a look at what can we actually input in the different queries in the software, and then we'll take a look at how can we get data towards there. If I open these queries, I can see that for the levels carbon, we have first of all our building materials. So these are the A1 to A3, which we discussed yesterday, usually sourced from any type of building information model we have, or cost plans, or we could also, of course, input their data manually. Then we have our energy consumption, which is usually the annual consumption. And this is our B6. So this is the energy. We have then water consumption annual, which is our B7. And then we have our construction site operations, which are our A5 emissions. Then if we're doing any type of assessment, be it either a building calculation or a carbon studies, we of course also have to fill in a calculation period. It's often done for 60 years, but if you want to do a calculation for a different period, you can of course do that as well. We then have a non-mandatory query, which are our use phase emissions, B1, which we can also include. And then we have our building area. So that is of course also needed to get the result, for example, per square meter. If I then check perhaps the other tool, the levels lifecycle assessment, I can see that the queries are identical. So the only real difference between these first two tools is just the type of output you get from the result page. And that's what we'll also be talking about later. If we then want to do building circularity, so we want to assess the circularity of our materials, we can also see that this is not expressed in any type of indicator like kilograms CO2 equivalent. It's expressed in a percentage. The higher the percentage of circularity, the better. So if we get a building which is 100% circular, we probably have one of the best environmentally performing buildings. If I click on input data there, we don't have so many queries. We only require really our building materials. We also need some weighing factors, which are covered later, and we'll need, just like the others, a calculation period. If we're inputting data under one of these tools, so perhaps we do it to the levels carbon right here, it would have the data automatically in the others as well. So it's quite straightforward. You do it in one of them and you have right away all the data in the other queries as well. Let's go over the different queries and then we'll look if we can automate perhaps the data there in a bit more automatic way. So the input data, I click and then we go to the building materials. The building materials query is the one we will be spending probably most of our time on, and also the majority of our impacts are probably coming from this, unless perhaps you also include energy. In the building materials query, we have first of all a filter setting. This will be useful later when we are actually looking at different type of data. So what do we actually want to include? We then have a completeness and plausibility checker, and this links into that setting in the design we made where we talked about, okay, we're gonna be doing a new construction building with a concrete frame. So later it will give us some checks. Obviously, it doesn't give us checks yet because we haven't inputted any materials. Then we have the different type of subsections. So the first section is only for the materials related to the foundations and the substructure. And then we have the vertical structures and facade, which has a couple of subsections like the external walls, columns, internal walls. Then we have our horizontal structures. So any materials relating to the floor slabs, ceilings, roofing, beams, etc. We can then have any other type of materials which don't really belong to any of the others. And this can also include the windows and doors and the finishes and any type of covering. Number 5 is then our external areas and side elements. This is usually not mandatory for most certifications, but if you would want to include landscaping elements or pavement or this kind of stuff, it can all go to number 5. We then have number 6, which is our building technology or MEP, depending on what terminology you want to use. So that is any type of technology which goes into the building, like HVAC machinery, heating and cooling systems, you name it, it can go there. Elevators, computers, anything related to that. The data itself, if you search for any of these sections, is exactly the same. So if I look for concrete under the foundation section, just by typing, let's say concrete, I'll find all those concretes. And if I do it under the building technology section, it does exactly the same. And we'll cover a bit more about what we actually get there in a bit. If we're searching for data here, we can do that, of course, with a free text search. So we could just search for concrete. We can also search for the manufacturer name, the material name. We can search for product names. But the best way to find data is actually with the EPD number. So if we have the EPD number for a resource we're looking for, we just fill that in and it will find it right away. Maybe one example I'll show here is if we have a concrete manufacturer from the UK. If I open it, this one is from Hansen. I'll open the data card and I'll talk about the data card a bit more in a bit. But under the data point background information, we also have this EPD number. So let's say I am a consultant. I have gotten from the manufacturer only this EPD. I don't really know anything about how to use this otherwise, but I can then copy this EPD number, which is right here. I'll just close this one and I'll just search. That is not copied, my bad. Let's see if it actually copies this time. And it does not. Okay, no worries, then I type it manually. If I type that specific EPD number, I will find right away that concrete that I was looking for earlier. So working with EPDs is quite good because regardless of what type of EPD program you're working with, you can always search for the EPD number and find the exact resource in our database. The EPDs are usually available only in the building materials query. So if we're working with EPDs, it will be on this query, and that's where you probably spend most of the time on. The other queries are usually a lot more straightforward. So you don't have to spend too much time on that because we calculate the data in a little bit different way. When we are automating data, this is usually only possible to our building materials query. So if we're doing this from a BIM model or we're doing this from an Excel sheet, cost plan, doesn't really matter, that always goes there. If we're importing data from a BEM, a building energy model, then it's possible we can also populate at the same time the energy consumption query. But in most cases, I would say it's just the building materials. The energy consumption query is usually a bit more straightforward. Where we have thousands and thousands of building materials, there are not thousands and thousands of energy options. So if I open this query, we can see what we have there. The first section here, we have the consumption of grid electricity is only the purchased grid electricity. And it's always the annual consumption, same for the energy and the water. In these cases, we can search for specific energy mixes, which we might want to use. So in Finland, we have some type of average mixes available also, but we also have the basic profiles, which we source from the International Energy Agency. So depending on the country we're looking at, there is a lot of different type of data from around the world, which we can use to do our calculations. So if you're doing this later, just make sure you pick whatever resource you have available. If you have set up your project to a specific location, you'll already find that data highlighted, just like I have in this case, Finland on the top. We then also have fuel demands. Perhaps our building has a generator or uses some kind of fuel for whatever reason, for heating perhaps. Then we also have different type of fuels we can use. So there's quite a lot of options we can pick here as well. We have then district heating. District heating is not as relevant outside of the Nordics, but there are some options for other countries as well. So if I open this, it starts with a lot of Nordic data, specifically for Finland, but we also have data for other countries available. So still quite a lot from Nordics, but then we also have for other countries, usually at least 1 or 2 profiles. We then also have district cooling, and this is not really relevant anywhere outside of the Nordics. The only profiles which are available there are for Finland and Sweden. So don't worry about those too much. And then we have the section of exported energy. I discussed yesterday also shortly, if you remember, about the D phase emissions. And then we also had D2, which is exported energy. So if we are having solar panels or PV panels which generate some kind of electricity or energy, we can report them to the exported energy. And the exported energy is not attributed to the total score, but goes to the D phase. So I'll show you later how we can have that. If we are including any type of renewable energy, which is actually consumed by the building itself, then we can reduce that from the consumption of grid electricity. But I'll come back to that in a bit. We then have our water consumption, and this specifically talks about annual water consumption. There are not hundreds of profiles here. There's usually only a couple options. And in this case, the options for us which are relevant are only really these three. We either make a distinction between the clean water and the wastewater we have. So we would have tap water clean and wastewater from residents, or we can use the middle one. Water consumption is usually something you don't get from bill of information or a BIM model or anything like this either, but there are a couple of water calculators, for example, one from Bream, where you can get an estimation for the water consumption of your building. So water consumption goes to the B7 stage. We then have our construction site operations. So these are the A5 emissions. Any emissions which are only relevant or only happen during the construction of our building. So that's usually year 1 to whenever the building is delivered. Construction site operations we could do in 2 different ways. If we're in a really early phase scenario where we don't have too much information yet, we can do it with a scenario as we see here. There are different types of scenarios dependent on what type of assessment we're trying to do. For example, per square meter. And in those cases, the scenarios have been calculated, which includes some estimation of what we have there. So this is only good for early phase if we don't have any information available. If we are in a later stage project, so perhaps you're being contracted to do a building LCA assessment for a building which has already been constructed, then you usually have contractor data. So whoever has created the building or manufactured the building, they will have data for the energy use, what kind of electricity they have used, any district heating, fuel consumed, perhaps machine hours of machinery, and then also, for example, formwork, so any type of temporary materials which won't be part of the final building, and then of course, water, waste, and perhaps any additional trips. So in those cases, it's always either a scenario when it's early phase or when we're in later phase, we actually fill in the actual information in number 3 to 7. We then have that number 2, the demolition or deconstruction scenario, which is here as well. Technically, that accounts to the construction site operations, but it doesn't, it's not added to the A5, it's added to C1. Because of course, this is not something that happens at year 0. This is something which happens, for example, at year 61, or whenever we are demolishing the building. This scenario only generates emissions if we're using one of those 2 new end-of-life profiles. If we're using the material locked scenario, we just have that C1 to C4, so we don't get anything else there. But if we're using the market-based or the EPD end-of-life, we could add a C1 scenario, which then generates some data for us. The calculation period is, of course, mandatory in pretty much any certification scheme. Depending on if you're doing very specific certifications like Bream International, the calculation period might also be locked. So it could be that it's set to a period of 60 years because it's the default and you cannot change it. In levels, we can change it. But for example, if we do Bream or LEED, it's usually 60 years for a normal building assessment. We then have our emissions and removals query, and these are use phase emissions. So these are the B1 use phase. When we are looking at these queries, this is usually not mandatory. It is more common to have these included in assessments, but it's not required from a certification point of view. So usually you don't do this unless perhaps you have a client who specifically asks you to look at refrigerants or specifically asks you to look at concrete carbonization, vegetation carbon withdrawals, and so on. We then have the last query, which is our building area. And of course, we have to fill in a building area to ensure we can actually calculate our results. We can also click here already, mandatory data is missing. And because I had set up in the beginning already my building area, it automatically takes it there. For a BREEAM or LEED or levels project, we have to use the gross internal floor area as our definition, but there are more options available as well. These are not all used by this specific tool, but perhaps by other tools which require different type of service definitions. Like in DGMB, we have the DIN 277. In the Netherlands, in the Dutch scheme, we have the BVO, and there are different type of settings we can use there. So these all queries have to be filled in if we want to get the final results, but you can generate results from pretty much anything. So if I just include the building area, the calculation period, and the construction site operations, I already generate results. That is always visible on the result page itself. But if I want results on my main page, I'll have to fill in at least those mandatory queries. So for these examples, I would have to fill in the building area, the calculation period, the energy consumption, and the building materials. So the building area is now filled in. I'll just fill in also a calculation period. So I'll set this to a 60-year period. I'll go to the energy consumption, and I won't pick a resource with a quantity yet, but I'll just pick a resource so we at least have this met. And then for our building materials, I can just include, for example, one resource. So we can see that we have something. What I include doesn't really matter at this point, but I'll just pick a generic resource for some installation. If I click on save, it will calculate now the results for my material that I have here. So we can see we have 0.19 tons of emissions. It's 100% of this entire project. Also highlights that here. And now all these checkboxes are marked. So if I now go back to my main project, I'll just click on the summer school. It goes to my main page. And I can right away see that we have a score here. So the score in these two is exactly the same because they're calculating according to the same methodology. But I already have a circularity score of 6% as well. I can also see up here some limited information on what I have right now. So it's, for example, comparing my score to Finland office buildings. And well, I have almost no data. So now it looks like I have a really good project. All of my material data is pretty much coming from A1 to A3. And all of the data I have right now is attributed to the foundations and substructure because that's the only place where I entered data. I don't have anything else in these right now. So if I open these also, I can see that we have some data for the building materials. We have something for energy consumption, but I didn't actually enter a quantity there. We have the calculation period and the building area. If you guys now remember from yesterday when we actually looked at those different result pages, if I open the levels carbon result page, with the very little information we have right now, I can already see that we have some score. So we have the different life cycle stages. I definitely haven't entered data for everything yet, but we can see that there is already some scoring. The formatting right here is now in scientific format, but if you go to more actions and you set it to decimal, you can actually see the numbers in decimal format also. The only issue with decimal formatting is if the values are very close to 0, they might just show 0. They might not show anything else. So that is something to take care of. Usually, if we're doing an LCA, we set it to scientific format because it's easier to interpret the results that way. If I now go back to the main page and I show you exactly the same result page, but from a different tool, and in this case, the levels lifecycle assessment, we open that here. Oh, my bad. We can see it's pretty much the same, but we have more indicators. So I'll just set this also to decimal so you can see what that does. So we have the same life cycle stages, but we have more indicators. We have, of course, the global warming potential, which was also in the levels carbon. We have the biogenic carbon, which is only relevant if we have organic materials, but then we have more indicators in line with the EN standard. So we have the acidification, the ozone depletion potential, etc. But we also have some indicators for use of primary energy and water, and then also some data for the site impacts. So depending on what type of tool you're using, you can have different type of indicators on the result page, and they always have data which is only relevant or basically provides the relevant format for that specific certification. So the BREEAM or the LEED tools or DGMB or the French tools, they all have data in a different format, but usually the source data can be the same. If I go to the main page and I'll quickly navigate to the circularity, we haven't covered that yet. I'll go to the result page, and then we see we get a quite different view. So here we have our circularity score. So I have only included 100 square meters of an insulation material here, but we can already see from just this small quantity of data that the circularity score isn't that high. There's a lot of virgin material there, and actually all of this material is currently disposed of, so quite low circularity score. When we want to actually check the inputs for the building materials, I can go back to the main page, but I can also click directly on the input data and navigate to the different queries we have there. If I click there on the building materials query, it opens also this one, but here it also looks a little bit different. So we have access to the exact same set of data, but the queries there are just different. Now, if I go back to the main page, and we can take a look at how we can automate the data a bit more, and then we'll also cover the building material query a bit more in depth. If we're clicking on any of these input data buttons, doesn't matter if there's already a score or if it says input data, we can of course go manually into all these queries, but we also have options for automated data import. We can see here under the import data that we have the option to do this, for example, from Excel or from another software. We can also do this from Carbon Designer, the early phase baseline tool, but I'll cover that during session 6. So I won't cover that too much today. I can also copy it from other projects if I have multiple projects already done with our software. The import from another software will be covered during the session 7 by Marios when he talks about, for example, the Revit and the Excel import, but I'll just run you through the import process once here. I'll click here on input data and I'll click on input Excel or GBXML. And now we start our import process. So we can see that the import process is actually a couple of steps. And this is the same for all the type of import we are doing. So it doesn't matter if this is through Excel or Revit or any other type of BIM software or CAD software. First of all, I have to have a file. So I can use any type of file I have, but the file has to be in a certain format so that our software can read it, of course. You can click on the help button here, which takes you directly to our Excel page. So this is our help center page on Excel, which also talks about a couple of templates we have available on the bottom. And the template in this case, which we want to use, is our metric version 4.4. I'll just open it to show you how this looks. So this is an example template which has some data, but you can of course also replace the data there with your own data. If we're having this base template, there's a couple of columns which are mandatory. And those are those first 4 columns we see here. I'll make it a little bit bigger. So we have our class. The class decides to which building elements or materials belong to. And we already have some pre-filled options which you can select there, which translate and make sure that the data goes to the right place in our software. We then have our IFC material name. So these are basically the material names which will help you make choices from the database. These names should always be specific enough so you can actually make a choice from the database. If we take an option here, we see that we have a precast concrete and a ready mix concrete, so different types of concrete. And they also have different type of strength classes. That is a type of information you want at minimum, so you can make sure you take right choices. We also need to have the quantity and the quantity type. Of course, if we don't have these two, we will actually not be able to link it to any options from the database. Quantity is very important, but the quantity type also. So there's only a couple of quantity types which are supported. If we have concrete, this is usually recorded in cubic meters or perhaps square meters with a thickness. So that is possible. But there's also the option to report on unit. There is not a lot of EPDs which report their quantities in units. So that's one which I would recommend to avoid unless you really know what you're looking at. Any of the other columns we see here, like the thickness or the transport, they're all optional. You don't have to fill them in, but if you want, you can enter some data there. Then there is a bunch of other columns there which are really specific to certain classifications. Like we have the Braham classification there. We have the Norwegian Bygningdel, the Finnish Talo 2000, but then we should also have the levels for the one we are using. So depending on what you're looking for, you can just ignore most of these. But if you want to make your life a bit easier and already apply some kind of classification system, you can do that as well. So I'll now look at how we upload this data and go through the different steps of our import process. I'll just close this. And I'll close this one also. And I will select this file for uploads. When we do this Excel file import, we load the data under the Data tab. But if we're doing this from any type of automated import, it sends the data from the software you're trying to import from and starts directly at the Settings tab. So if you're doing that later, just make sure if you see that you're starting directly at Settings, it's okay. It's fine. We then have a bunch of settings we can do. We have the project we want to take the data to. We can also choose the design, and we can also merge data if we want to. If we're using imperial data or metric, depending on what your setting is, you can also convert it right away to the other system. And we can also pick the tool. So for this example, maybe I'll take it directly to the Levels LCA tool. We then have some filter settings. So if we're doing an assessment for a certain scheme, we might not want to include all the materials because it's simply not needed. So depending on what we're doing here, we select whatever meets our requirements best. We can also merge data, as I said, or only add new data or only update quantities depending on what we're trying to do. And if you're actually downloading this or you're starting this import process from Revit, you can also download the bill of materials directly in Excel format. With some of our expert features, it also allows you to actually send data to other users. So perhaps if you're working together with one of your colleagues or friends on the summer school, you can also try to send each other some data and continue with that. If you send data to somebody, they of course need to have access to Click LCA with a specific feature, this send me data, and they'll get an email which tells you, okay, your colleague has sent you some data and you can use it to start your LCA. We can then click continue, but we can see that there's a couple of steps which are checked here. We have 6 steps in the process, and of which 2 are always mandatory, or at least heavily recommended, which are our combine and our mapping steps. I'll just select all these. And first of all, we go through the classify step. In the classify step, we have to make sure that the data goes to the right place in the building material query. In the filter step, it kind of is similar to the filter settings right here. We can still take out some data we might not need. In the combination step, we're trying to reduce the amount of data sets so we can have a better overview of what type of data we're moving forward with. So if we're doing a building assessment and we have, let's say, 1,100 elements of a specific type of concrete, which is all for the foundations, there's no reason why this should be 1,100 separate data points. This can be just one because it has the same function in the building. So this is really to speed up our LCA and make it more streamlined. The review step ties in with a checker we have called the model checker, which checks the quality of the data we're uploading and if there's perhaps any errors in those. The mapping step is then kind of the most important, where we actually have to make sure that all the data we're uploading is assigned to options from our database. So that is the point where we actually tie them in with emission values, and that's of course where we get our results from. The updating tab is useful if you're re-uploading an existing file, which you perhaps have made some changes to. But in this case, I will skip it because I'll just do the basic import. Then if I click on continue, it will now take me to the classifies tab. We can see here all the classes which it saw from our Excel sheet. It can see the classes which it assigns them to. And then we have our target location. So all this data goes to the building materials query. So as I said before, also when we're doing an automated import, the building materials query is the only query you can really import data towards. We can also do energy, but that would have to be from a building energy model. That is, of course, not included in our Excel. Under the filter step, I could decide to still take out some data. Perhaps I don't want to do internal walls, or I don't want to do finishes or anything like this. I could take out whatever data is not needed at that point. I will just leave it all here for now. And then we go to our combination step. The combination step will not do so much when I have such small amount of data points. So in this Excel, it's just 21. But if we're doing an assessment, let's say a carbon studies of a mall, or perhaps we have a big residential building which has 20,000 data points, we will try to reduce everything as much as possible. And then we can also apply different type of grouping criteria. This will be explained more during the session 7, so no worries if you don't really understand it right now. But basically, by default, we have to combine on a number of these parameters. And those are the class of the material, so where does it belong, the name of the material, and what type of quantities we are working with. Then we go to the reviews tab. And in this case, if we have any issues with the data we're uploading, so perhaps we have received a cost plan or a bill of information, which is from an external party, we have no idea what the quality of this is, it will be able to flag issues. So if you want to check more about this, you can also check the help center for the model checker. But with this Excel, since it's really just a template, it doesn't really detect anything, of course. There's no issues with the basic data I have here. I can also see the materials information here. Under this little paper icon, which you'll see at some point throughout the software, you can usually find any type of information of data which was uploaded with what we have here. We have any comments. If the classification is already assigned, which in levels is called building parts, we can see that as well. We can see the quantity of this, and we cannot see a share yet because there's no emission values linked to these yet. If we want to remove some data at this point, that's of course also possible, but since we're already so far, I'm not going to remove anything anymore. Then we go to the last step, which is the mapping step, which is pretty much the most important step here. In the mapping step, we have to make sure that all the data we're uploading gets identified. So this Excel, which I have already used before, already has 100% identified data. But if you're uploading your own Excel, which is perhaps in a language which is not as commonly used, or perhaps you have given your names really specific material names, it's possible that it doesn't see everything automatically. If we do have identified data, it looks like this. So we have our material names, all the information, again, you can find there. Then we have the comments, the classification, the quantity, and the share. I can then see what these have been mapped to. So we have some gravel here, which I can see is linked to a resource which is called aggregate from a crushing plant. And I can see it's mapped because another user from my country, in this case, has mapped it. But I can also see that there is another resource here, asphalt, and it has been mapped by another user from the one Click LCA software. If I scroll lower, maybe there are some other options, but unfortunately not. So what we employ here is kind of a smart mapping system. If the material names, which you have here on the left, are recognized by our software, it will try to automatically map these to an option from the database. Like we can see that there are multiple options, which is a links to here. And if the options are available, it basically saves you a little bit of time when the mapping. We can, of course, always fine-tune these as well. How this mapping database works is first it checks if your mappings are present. So perhaps I've made a choice before for an aggregate, it will highlight those first. If those are not available, it will try to go to mappings of my colleagues. So perhaps one of my close colleagues has made some choices before, they have done a similar type of projects, I could rely on their mapping choices. If those don't exist either, it will try to go for mappings from the same country. So perhaps there have been some other LCA consultants or engineers which have already made some material choices in my country, which could be relevant for what I'm doing, like you can see here. And if those don't exist either, we have the last option, which is global users. If the data you're uploading here, so the material names, have never been seen before, it will add a second line of data, which is unidentified data, which basically means you have to make the choice yourself. How this would look is quite simple. Let's say we have reinforcement steel here. I will remove this option, so we don't have anything chosen here yet. So it will just be empty in this case. It will normally also say that it's not identified yet. So then I have to start making a choice. I could, of course, just search for reinforcement steel or rebar steel, but I could also use this filter setting up here. So if I'm looking for reinforcement steel in Finland, I could go to my material filter. I could say we are looking for steel here. I'm looking for reinforcement steel, and probably I want to set this to Finland, so I only get steel which I could actually have locally available. If I open it then, I will start with some generic data, and I'll talk about the structure of this in a bit. But I can see there is actually also one manufacturer-specific data. So perhaps the steel for reinforcement profiles of cell size actually the one I will be purchasing for my project. So this would be probably the best match. I can then also see that somewhere in the list of the data I uploaded, there's actually another material of reinforcement steel, which could be pretty much the same resource. So I could decide to do this one at the same time. And that was actually that one up here. So depending on what choices I've made, I can decide those options, and then I can also save the mappings so that I know that for the next time when I do this kind of assessment, it recognizes all my choices. So it is possible that if you have a quite specific way of naming your materials, that the first time you have to identify some of them, but after that, it identifies most of them automatically. If we have done this process, we always have to make sure that we end up with 100% of data. If you're uploading a file and let's say you have 300 unidentified data points, you might not have the time at that moment to right away select all of them. So what you can just do is go to your list of data, map as many as you have time, and just make sure you click Save Mappings every now and then. Because then if you do this again later, let's say we stop this entire process right now, I have some dinner and I boot up Click LCA again, and I again go in this upload, it'll recognize everything I've just done before. So the Save Mappings tab is very important here. If I then click on Continue, after I have identified everything, it will take me directly to the results page. So I'll just show you how it does that now. Usually takes a few seconds, so wait a bit. I would say that probably normally it doesn't take so long, but I guess we have quite a lot of people online right now doing similar things. So there we are. So now it takes me directly to the result page, and we can see we already have some overview of the type of data we have. So just from uploading this Excel, we can see that we have data for different type of life cycle stages, like our construction materials. We already have our default settings from transport. We have some default settings also from the construction site operations. We don't have any replacement yet because we don't have a calculation period set, but we do already have end of life data, which comes from our end of life setting in the LCA parameters, and also some dephase data. Also for the different type of indicators, it automatically populates them also with the data which is available from the EPDs. So based on just this Excel, we can already generate quite a wealth of information. But of course, in order to have everything, we do have to fill in more. So what it now tells me that I have at least these queries missing. So let's populate these, and then we'll cover a bit more in depth the different queries we have. Area definition, I'll just set this to what I had set in the beginning, so 2,500 square meters. I'll set my calculation period again to 60 years, very common calculation period for these kind of definitions. So we set this to 60, and then we have our energy consumption, which we will set our, maybe I won't really fill it in, but I'll at least choose a resource so it highlights the checkbox that it's generating some data. Just have to wait until it navigates there. And we can see it also has already calculated some data for the replacements now because I've just added the calculation period there. So I'll enter some resource. Maybe I'll just give it a small quantity of data, 100 kilowatt hours. It's not that much, but it doesn't have to be that accurate in this software training, of course. So now based on my calculation period, it automatically calculates those energy quantities also. And then we can go to the building materials query. So let's cover the data we have here, and then I'll show what we can actually do here and compare, for example, these materials. So the first thing we have, of course, are the material names. So these are the ones which I had linked to before. Some of them were automatically mapped. And we, of course, have then the data cards. In these data cards we have, and maybe I'll select one more if we have some manufacturer specific, we can find quite a lot of information. So we have on the left a manufacturer specific, so an EPD, It does say it's expired, but it doesn't really matter too much. And on the right, we have a generic resource which has been made by our data team. Under the generic information, we usually have some information on the country, the manufacturer, what type of material it is. So we can see we have a rebar here, and we have a ready-mix concrete. Under the next tab, we then have our data point background information. So this includes all the type of information regarding to the EPD program, if there are any specific standards which apply, and also, for example, those third-party verification rules, plus upstream database. If we then go to the technical characteristics, it usually has some kind of information about the resource itself. So if we have a thickness, a default one, what kind of units we can report it in, and also if there's perhaps density information available. If there is a description, and this is usually taken from the EPD, it also talks about what information we have there. So it's not always available if the manufacturer, for example, hasn't given the information there. And then we have our environmental profile. We can see the environmental profile has the emissions we have. So the emissions for A1 to A3, as those we take from the EPD. We can also check all the emissions if we have the data there. And we can also see which performance group they belong to. So the resource on the left is part of the reinforcement for concrete, rebar. We can see the performance rating. So in that group, we actually have 235 reinforcement for concrete. And this one is number 20. But if we take a look at the one on the right, so this was our ready-mix concrete with a specific strength. This is part of the performance group ready-mix concrete for foundation and internal walls, and it has a performance ranking of not that good. So there would be much better options I could choose here. Then we have also some information on perhaps the default scenarios which are applied here. So I open this, I can see that the transportation distance for the rebar with the setting I've chosen is 110 kilometers, with the concrete 70. I can see the mode of transportation. So we have a truck on the left and a concrete mixer truck on the right. We have some wastage, so how much materials goes lost. And then if we have some end of life scenario, it also shows right away and what the emissions for the end of life are. So there's a lot of information directly available to you in the data card. The base information regarding to the EPD, you can of course always find by just downloading that EPD. We can just search for this EPD for example, the lifecycle stages. If I scroll down, there's, for example, this type of information right here. And that is what we actually would take. So the data card provides you with already quite a lot of information and also allows us already to look things from a bit more a comparison point of view if we want to compare data with each other. We then have our quantities. And if we want, we can also recalculate these to different functional units if that option is there. We have then our CO2. So what kind of emissions do we have for this row of data? If we open, for example, this glass wool, we can see that we have material emissions, so A1 to A3, transportation emissions, A4, construction emissions, A5. Then we have waste transport, C2, and waste disposal, C4. So the end of life very much depends on the type of material we're looking at. So not all materials will be disposed, but also not all materials will be reprocessed. We then have some extra information on the comments. And also, again, you can find all the information back there. Then we have a classification system, and then we have our transportation. So depending on what settings we have a transportation option here. In some tools, you can even report on multiple transportation modes. The service life setting then is also quite important. If we have any materials which are belonging to our foundation section, so the number 1 here, the service life there is always considered to be permanent because the foundation of the building will not be removed throughout the service life of our building. But of course, would be a bit weird. Any materials which have a shorter service life setting will have to be replaced. So if I just pick one here, we have, for example, a row of bitumen sheets for our roofing probably. I can see that the service life period there is 20 years. If I then open this one, I can see we have our initial 1.6 ton of material emissions, but we also have double that in replacement emissions. So this material would actually have to be replaced at year 20 and at year 40. So depending on the service life setting, which you can change, you will have material replacements, which are of course your B4 and B5 emissions. We then have our localization setting, which I would recommend to check in a bit more if you want to know more about it. But if you have data which is localized, the emissions will be changed. So if we have data which is already local, like we have, let's see, is there some local data? We have some reinforcement steel here, then it will not be localized. And if we also check more in the C calculations, we can see just the pure calculation of how the software calculates it. But if we have data which is not local and will have to be localized, perhaps I will find a resource here. Let's say these bitumen sheets. This is a resource from France. If I then take a look at the C detailed calculations, it will also have a compensation factor and impact. So this is the localization which kicks in, which makes sure that this data will now be adjusted to represent local manufacturing conditions. If we then go further, we have our B3, which is the repair rate. If you've paid attention yesterday, you'll know that I have said that for B3, no real methodology exists. So it's a bit tricky to estimate on how to report this. If you want, it's just usually a couple percent, but you really have to do some research yourself to get these values accurately. We then have our material wastage. So this is how much material goes lost upon installation in the building. So this is attributed to our A5 lifecycle stage. So any emissions which happen during construction of our building. These can, of course, also be changed. We just have default parameters or default settings here, which are based on our material type. Not all materials have wastage, of course. If we, for example, have some hollow core concrete slabs, or if we have doors or windows or whatnot, they usually don't have wastage percentage because they're not cut to pieces anymore. They're already pre-made. We then have our end of life process. And the end of life process only shows up here if you have chosen one of those more advanced end of life processes, which is the market-based or the EPD end of life. It chooses the most common end of life process, which is relevant for the material, but you can choose other options if they are available right there. That, of course, directly influences the C1 to C4 and the D phase emissions. We then have the option to also mark materials as reused, which basically eliminates the A1 to A3 and the A5 emissions. If it is part of the structure of the previous building, perhaps we're building an office or renovating an office and we have materials which are already there, we can, of course, also set our transportation to 0. There's also a really good article on how to use this feature. So if you want to know more about it, I would just recommend to check the help center. So you could, for example, go here and just type reused and you can you check that article and you see it right away. We can also change resources, and that can be done with the change button. With the change button, we can copy data, we can delete it, we can split it, we can lock it to make sure we don't change it, but we can also replace or split it. If we replace a resource, we basically take our original resource and change it to something else. If we split it, we take our original resource and change it into multiple resources. So if I would just show this option, we'll have on the left side our original resource. And then in this case, it's gypsum. And then I could choose from the database for any better options. So perhaps for this gypsum here, I can see from the environmental profile, it's not doing that good, 288 out of 364. I set it to Finland. And perhaps now I use my CO2 filter, which I'll cover in a bit, set it to very low. And I only find the really best options for gypsum that I want to use. So we have a gypsum from Saint-Gobain, seems quite okay to me. And it is indeed much better, number 66, and the emissions per square meter are also much lower. So these kind of ways you can use to change your emissions quite easily. On the whole idea of optimization and taking better resources, that will also be covered in sessions later. So I won't dive too deep in that today. We then have here also the completeness and plausibility checker, which is based on, for example, the scope we set and what kind of materials we include. Now, of course, what I'm following here is nowhere close to the scope of levels. So it tells me that my analysis is not really correct, but that's fine. If we're doing a scope or if we're doing an analysis according to a certain scope, it will tell us if it is correct. We also have the LCA checker. So the completeness checker checks the scope, and the plausibility checker really checks how accurate our data could be from an LCA point of view. So there's a bunch of checks it does here. We can see we have a total area, 2,500 square meters. We have a concrete new building, and then it checks certain things of values, what it expects. So for example, it tells me the finishes mass could be credible for a building of this size. The replacements is higher than 10%, so that's correct. We do have quite a lot of dominant materials, but there is a lot of checks which are not meeting our requirements. So for a whole building LCA with just the basic Excel I uploaded, it's simply not going to be enough for what we do. So I will close this. I'm not sure who's talking, but could you try to mute yourself? Thank you. So yeah, basically we have a bunch of data here, and we can also search through the data here in different ways. So if we're trying to find resources, the best way to find them is usually with the EPD number, but perhaps we don't have an EPD number, or perhaps we don't have so much local data, and then we can use our filter settings up there. The material filter gives us different type of material types. So we have, for example, asphalt, bricks, and in all these, we also have subtypes. So if we have glass, there will be different type of glass we can find, and that can really help us narrow down exactly what we're trying to look for. The filters can also restrict what you're looking for, so just be a bit careful if you have filters set, and after every search, just make sure to click the clear one. So let's say we're trying to find the best safety glass pane. If I then search through these data, it usually starts with some generic data, in this case, regional generic data. But if there's local data, it would prioritize that first. Of this regional generic data, this is data which could be, for example, representative for all of Europe, since this has a European flag. And then there's some regional manufacturer data, which also pretty much represents all of Europe. But then we also have data which represents, for example, Sweden, or we have some data which represents France. And depending on what type of data we're looking for, that is all represented there, of course. Out of the material filter, we could also use the country filter. So if we're looking for a specific resource from, let's say, in this case, Finland, and perhaps I'm looking for a paint from Finland, it will highlight my only paints, which I find right away from Finland. If I lose the Finland filter and it only searches for paints, I will get a bunch of different paints. So then I could choose from all these options for what are we looking for. We then also have our data sources. And the data sources are those program operators I discussed yesterday. So the program operators usually have local data. So if I search for the Finnish RTS scheme in this case, it will show me a lot of Finnish data. But it can also have data from other countries. So a program operator doesn't necessarily mean that it only has data for that country. Even though RTS has a lot of Finnish data, we can see that there's also a lot of data with other flags, which means it's represented or it's manufactured in different countries. The type filter is also something we kind of discussed yesterday when we talked about what types of data do we integrate. So we have the generic data, which is usually industry average. It's always marked with this little X sign, as you can see here. But we also have manufacturer data, and this is usually an EPD. Generic data can also be covered by EPDs. Then we have plant data, which is also manufacturer data, but from one factory. And then we have a fourth option, which we won't really cover here, but that would be private data. We then have an upstream filter, and this is not as relevant if you're not doing direct product comparisons. But this basically looks at what kind of LCI or upstream data has the consultant or the manufacturer use to record the emissions of their product. If you would open any of these data cards and you would go to the data background information, you'll also find the upstream database right there. And usually it's also, of course, displayed in the EPD itself. We then have also a CO2 filter. So when we are searching for data, perhaps we're looking for the best regular gypsum boards, and I open this entire list, we also see a lot of these carbon clouds. So these carbon clouds is how we rate the data or benchmark the data against each other in our database. So if we are looking perhaps for this gypsum, and I open the environmental profile, I can see the ranking here. I can also open the full ranking to really look at all the data we have in one specific benchmark groups, in this case, benchmark for regular gypsum, and really compare all the data here. Perhaps I want to exclude the really highest data. Perhaps I then want to look at average data from neighboring countries and then find everything below my benchmark or below something, and then I can find. So this I will also cover a bit more later when we're really looking at optimization, but the benchmark is a quite useful tool to find out all the information or all the resources in one specific group. If we would set, for example, the CO2 filter just to very low, instead of going to that entire benchmark, it only highlights the 20% best performing resources from this group. So then I wouldn't have to check through all these. I can just see everything, which is right away perfect. We then also have a unit filter, and the unit filter allows us to search for very specific resources which are perhaps only reported in certain units. So that can be a bit tricky. I only recommend to use that if you really know what you're looking for. And actually the same goes for our property filter. So depending on what you're looking for, you can use those two as well. If we have all the data here together, perhaps we have entered our building materials, we have entered our energy and water, we entered some construction site, then we can try to see if we can get the full picture of our assessment now. I'll just have to navigate to the construction site operations because I know I haven't added an end of life demolition scenario yet. So I'll just enter that one and then let's see how we have it displayed now. So in this case, it's a scenario which is coming from the RICS guides, and I'll just set it to the same area of my building. Just have to wait until it saves again. And we can see our totals now. So if I now go back to my main page, and I'll actually select my option 2, I can now again compare it, and we can see we already have some more data there. I'm still comparing it to this Finland office, but I could also do this to different benchmark groups. But we can see now we have the option 2, and we also have a different circularity score, 30%. And if I now go to the result page of this one, I can right away also see all the scores right there. I could now also go into the details to really narrow down exactly what is contributing how. I could go up here and I could also compare designs. I can also get a results report or even send the data to another user. If I scroll all the way lower, we have also those different indicators. We have again that checker there, and we have the most contributing top 25 to global warming materials, if you have more than 25 materials, of course. A bit lower, we then have a variety of different type of graphs. All of our graphs you can just navigate through quite easy like this. They all demonstrate slightly different things, and you can also usually download them either as image format or as Excel or CSV formats. You can also change the impact categories if you have a tool which supports this. Of course, if we're doing a carbon study, we usually only have global warming potential, but for example, in the levels tool, you can do much more. So I'll cover all of this at a later stage, also when we talk about the results interpretation. We also have a list of all the data sources right there, which you can also access. So now if we go to the main page, I'll just cover the building circularity part still, and then we can answer some more questions about specific data. When we have the building circularity tool, we can see it's automatically populated already with data because we have already inputted data in one of the LCA tools or one of the carbon tools, perhaps. From the circularity point of view, we need our material data. We need our calculation period, and both in this case are coming from there. And we need our circularity weighing factors. The circularity weighing factors decide how do we calculate the value of our materials. So how do we calculate them into our circularity score? If we have materials which we are sourcing for the project, so what we are recovering, virgin materials are usually not counted because it's not really a good practice and they're usually high in emissions. Anything which is renewable, recycled, or reused is counted fully. So we can see it's shared by number 1. If we're looking at what has happened with the materials after the building is deconstructed, so the potential benefits to recycling. So if you have checked yesterday about the D phase, you'll probably see that reuse, recycling, reuses energy, probably is quite familiar. Anything which is reused as material or recycled is counted fully. Anything which is downcycled, which for example means that if we have concrete which gets reprocessed, it turns into aggregate, but it will not be concrete again, it will be counted half. If we have anything which is reuses energy, so perhaps we have organic materials which are incinerated, where we have some energy recovery from, but of course it generates some emissions, it's also counted half. And anything which is down disposed, so landfill, we don't count. It's a bad practice. So that is 0. Then the calculation period, as I said, was coming from the project, and our building materials are coming directly also from the other design in this project. We can see it doesn't have emission values here. We have, of course, the same resources. We have the quantities in the comments, but it skips those emission values because they're not as relevant to our circularity score. What is more relevant is these percentages of recycled, renewable, and reused. So these values come from EPDs. If a manufacturer states, for example, with the steel profile here, that this resource, for example, is 90% recycled, it will take that value right there. These you can always update what the values come from EPDs. So if you want to stay true to them, you can make sure you use those correct values. The wasted values, of course, also depend from a circularity point of view because these are materials which will be replaced or wasted, so extra materials we would have. And then we have a design for disassembly and a design for adaptability principle. These both principles are good to consider from a circularity point of view, but do not apply to this total circularity score. So if you want to read more about that, I recommend you go to the Help Center. You just type in here circularity, and you just read this article right away there. We then have also the end of life processes, and where from an LCA point of view, the end of life process directly affects the emissions, here it affects the circularity. So if we have materials which are recycled, the end of life, the circularity score will of course be higher. And anything which we don't do anything about or is landfilled is not counted as nicely. If we then go to the result page, we'll open this and we'll then see our circularity score. So the circularity score, as a rule of thumb, is the higher it is, the better it is. The most circular buildings have usually a very high score. If we take a look at the source materials, we can see we have a very high percentage of virgin materials here. So new materials which have not been reprocessed before, so high in emissions usually, those are not counted in this case. Anything which is renewable, recycled, or reused, as I said, they are counted fully. So that takes us to the 9.2% for the materials recovered. We then have our materials returned. So what happens with our materials after the deconstruction? So benefits to this building. Anything which is disposed of, we do not count, bad practice. Anything which is downcycled or reuses energy is counted half. So those are counted half only. Anything which is reused as material or recycled is counted fully. So then we have our 50.8% and our 9.2%, nice 60% together. We slash it in half and we have our 30% circularity score. Then, of course, we have some little result parts here also about the materials recovered. So how much tons of materials are virgin, how much are recycled and whatnot, what is happening with these materials after, and then also our key material groups. So we can see that from the first line, our concrete, 100% of this concrete was virgin, but we can downcycle all of this concrete because it's not precast, it's probably ready mix. 50% of that would be then materials returned, and that makes a circularity score of 25%, not that high. There are, of course, better options for concrete also, which we could pick, but we'll discuss that in another session. Metals usually can be recycled quite well, so we see a very high circularity score, and the same for any wood or biogenic materials because these are renewable. We then have a small section on the transport, and if we have assigned any design for disassembly or design for adaptability, they're counted there as well. We have some graphs here also, but not the same amount of graphs as for the LCA because not all of them are relevant here in this case. Just like with our LCA tools, we also have a results report you can download there, and we can also compare the data with each other, of course. So in this basic software training so far, we have looked at the different type of features we have. We have looked at the different type of tools we have, the type of settings we have, a little bit about the data, and also a little bit about what kind of results we get there. There will be some other sessions where we'll dive more into actually the optimization and how do we actually do these assessments. But this basic software training is very useful just to make sure that you know where everything is, how you can get started. So we have, based on this session, also a homework assignment, which, where do I have here? Let me share this one again. Maybe I'm a bit too fast now. Okay, I'll get to the homework assignment in a bit. How do we get access to the summer school license? So this PowerPoint was sent out before already, so everybody should already have access to it. And it also demonstrates how we can actually access the summer school license. So from today on, you can access it. As we said before, you first have to have an account. You have to have activated your account. And then we have to create a project with the license key, as I showed in the beginning of this step. So first, just go to our website, go to oneclicklca.com, select login. If you don't have a user account yet, you can register there, but otherwise you can fill in your username and you can log in right away. After you've logged in, you probably see something like that there are some trials available, planetary, but we just picked the building. And instead of linking it to a trial license, we don't do that. We enter the license key. So we have one license key, which is valid throughout this summer school, which is called LCA Summer School 2021. If you enter that and click on the activate license, it will see that it sees the summer school license. And then basically you have to go to the first parameter setup. So we choose the design, we select the name for the design, the tools, the LCA parameters, depending of course on our project location. And then you can basically go through all the steps of your calculation. So you can look at some manual inputs, you can look at some options from Excel, or perhaps you want to import from a BIM software or anything like this. So there's a lot possible. For the homework assignment for today, I basically have a checklist for you, which means that you should familiarize yourself with the One-Click LCA. So the checklist is right here. So you can also see this in the PDF if you get it, but basically just go through everything what I did today. So we look at the basics of creating a project, activating it, making a new design, include some materials, perhaps change some LCA parameters. You should look at the different queries. So look at what we have for energy and water and fuel. Perhaps look also at the construction site operations and also see what it does to the results if you change your building area and your calculation period. We have the different tools. So you can check what is the difference between the Levels Carbon tool and the LCA tool. And of course, navigate a bit the type of data we have here. So perhaps from the session yesterday, you can remember what kind of data we talked about, what is there. So we have the EPDs, planned data, generic data. So kind of check what the difference is there. We can then, of course, also make changes. So perhaps change the transportation distance, see how that affects your A4 emissions, change the transportation modes, use a boat instead of a truck and see what you get there. Change some material service lives, because that, of course, will depend on when the materials are replaced. And also, of course, go to the results, perhaps make two designs, make some changes in one, and also compare them with each other. For most of these elements we discussed today, you can also check the Help Center, which I've shown multiple ways of how you can get there, and they will explain on all the different aspects we went to today. So then we have some time for a Q&A session now. So I hope that some of my moderators have already answered questions, 99 of them. Thank you very much, guys. That is amazing. So I hope you can see the Q&A section now. I was checking yesterday if there is a better way to display it, but it really didn't work, unfortunately. Let's see if we can answer some questions today still. We have JM who is asking, can we include local data in consumption lists for district cooling and heating? You can if you have an expert license, but it's not included with the summer school license, unfortunately. So you can enter your own data. The data we include for district heating and cooling is only from like respectable sources which we use. Meyer asked in the chat if we can upload today's session just after the session. I don't do the upload, so I'm not sure if that will be possible. But worst case, it will be tomorrow morning. But you can always check them back later. So it's not, you're not in a hurry to check it already today. Metha Naik asked, why is the use phase not 0? It kind of depends what you include to the use phase. So if you yeah, of course. So I hope you see the registering now here. So the use phase depends on what you actually include there. So if we have just, for example, the, how do you say, the concrete carbonization and the vegetation carbon withdrawals, then we would have like positive emissions, but it would never be 0. And use phase can also, of course, include the replacement of emissions, or replacement of materials. And those are also causing emissions. So usually it's not 0. Nawapan asked if we can use the EPD number for the IFC material names in the Excel sheet. If you have the EPD number, it would indeed be possible to already link these automatically to options in the database. Just make sure you have written it correct in that case. So usually you can copy the EPD number directly from the EPD, and that would always be the best way to find it. I see Fernando had asked it already. Thank you. In the Excel, Rosanna asks, in the Excel templates on the material part, if I click the precast concrete, will it show me other options? The Excel template really just has basic information. It's just basically test information there, so you can remove it completely if you want. You don't have to use that Excel. It's just example data which you can upload, and you can see some information for it. So you can also remove everything and put your own data. Similar question as before, if I insert the EPD number, will it automatically load the corresponding resource? It can, but of course, you also have to take into account here that one EPD can cover multiple products. So it could be that you have one EPD number for 40 products, and then of course you still have to make a choice. So usually it's good that perhaps add the EPD number to the comment field or something like this, and then just search for the EPD number when you're trying to match it to a resource. It might be better. An anonymous question asks is, how is the D number in the example so big? Can be any case really. It's possible that I have just included resources which have a lot of benefits for recycling, like organic materials. I'm not really sure what I actually put in the example there, so don't put too much value on that. An anonymous attendee asks, which life cycle assessment parameters setup need to be selected? Well, you can select whatever you want, but if you're doing a normal assessment, you should at least do the transportation, because otherwise you don't have data for that. We should, of course, have our service life values, so we know when our materials are replaced, and probably you want to have the end of life also. So those I would do as defaults. They also say that they're mandatory normally if you do it. Metha asks, if we are considering the design phase, then why do we include the end of life without adding use phase? Well, you can include anything at any moment. If you only want to look at design phase, you can also exclude the end of life if you don't want to look at that. So it depends. If you enter anything in our software, you'll get results. If you want to do a full LCA, you should, of course, try to include as much as possible. But you can also just look at certain phases. You could even just take the A1 to A3 data from the result page. It doesn't really matter. Air Sarika asks, can it be helpful to evaluate any heritage value structure? I'm unfortunately not really sure what that means. If you want an answer, could you send that to our support team and we'll get back to you tomorrow on that. I cannot answer that right now, unfortunately, unless maybe one of the moderators knows how to answer it. Let me just read this one. Ta has a question about retrofitting and restoration projects. Basically, the question is, if I want to show my material and energy upgrade in terms of its effect on CO2 emission, what kind of procedure should I follow? So you want to show if your building is more environmentally friendly after a retrofit. Best way I would say is compared with, for example, a new constructed building. So in the retrofit, of course, you're only including the materials which will be replaced and anything else is not included. So if you compare this with a new building of the same size, it will have much, much more emissions. So this is a very easy comparison you can make at that point. And this will also be covered in some of the other sessions where we really look at optimization. This is just the basic software training today. Fishalaxi, hope I pronounced it correctly, my bad. At the end of the analysis, does the tool also suggest the best case scenario or option suggestions for which areas can be improved? On the result page, as I showed earlier, you do have that top 25 most contributing materials to global warming potential. So global warming potential is usually the most important one. In that case, you could see, okay, maybe the top resource I have is a concrete, which makes up 40% of my emissions. And then you can actually also check there what is a better option. So it gives you options to choose from. That will also be covered in the next sessions. Tara says, I couldn't see the options shown by Steven. I'm not really sure what options you mean, Tara, but it's possible that something maybe didn't display correctly. If you want to elaborate on that, feel free to put another question there. The option maps. You mean the resource options or? The types of graphs. So on the result page, you'll have all the graphs, but I'll put it on the screen where we have those. So if you check the PowerPoint right now, it will tell us there what type of graphs we have. So we have all of the advanced graphs. And if you have the PDF, you can also click on these links and it will take you actually to them. And of course, if you just access the software, you can see them on the result page right away. So I hope that answers your question. If you don't see it on the result page, you might have to still enter some data to your project if you don't have anything yet. So on the result page itself, if I just quickly navigate there right now, I'll just make this a bit smaller. We have all these different types of graphs there. In this project, I don't have so much data, so it doesn't really show too much, but there's a lot of different type of graphs available. Maybe I'll set this back to this one. Miriam asks, I want to ask about concrete products, please. Every time I save the product and come back another time to the project, they change. And in this side, I have no more mappage, but set of users name. I'm not really sure what you mean in this case. If you have very generic material names, the mappings are not automatically saved. So for example, if we have a row of concrete and we just put there concrete, it can really be any of 10,000 options. So it doesn't save that automatically. But if you change your material name to, for example, be ready-made, a ready-mix concrete for external walls and doors with a 20% recycled content or anything like this, that name would be specific enough so it actually remembers it the next time. So try to make your material names concise enough so you can easily recognize what they are for, and not just wall or concrete or wood or anything like this. An anonymous attendee asks, how can we decide on the weighing factor for the circularity toolbar input? Is there any previous assessment we need to do? Not really. The weighing factor we have there is basically our best interpretation of how you can do it accurately. But if you want to change it, so for example, the burning of material, the incineration of wooden materials, you do not want to count as positive, you can change that, for example. There's a lot of interpretation on what is the best way of circularity, and we just have our best way, but you can change it, of course. Also, I recommend to check the circularity article if you haven't read it yet. A question from Tatiana. It would be great to understand what kind of parameters are used to populate the model with. For instance, add a parameter EP number and fill it in. Will it work? It can work. If you, for example, have a Revit model, you usually have a parameter which allows you to also fill in the EPD number. You could use that for making your material choices. There are some articles on best practices for BIM modeling, which you can check in our help center. Perhaps I'll just quickly show one of them. So if you have, for example, BIM modeling, there are the detailed guide to BIM modeling and building information model creation guidelines. Perhaps you want to check those. This is a topic which is more covered in session 7, so I won't talk about it too much during this session. A question from Sophie, we will receive some sample questions to the exam next week. I haven't considered that yet, but I could possibly make some sample questions for this Friday, just so you get an idea of what we'll ask. But as I said earlier, also, if you have checked the recordings or if you have attended the sessions and you possibly have done some of the homework, at least checking Click LCA, then you should have no issues passing the exam. There is a question from an anonymous attendee. Can we discuss the previous day homework in the brief before we start the webinar of today? Unfortunately, we don't have so much time for that because it's so limited. What you can do is if you are in the Click LCA user group, you could discuss it there with the other members of the summer school, and perhaps we can give some comments there. Fortunately, we just have 2 hours every day, which is quite limited. So. And another question on the homework as well. Unfortunately, we don't have so much time to really go over all the homework because we have a lot of attendees, unfortunately. But perhaps that could be something we can improve on in the next option. And Dieter asked if when a question is being answered live, it's not possible to find a question in the list. Would it be possible to email the questions that were answered live so we can follow it in the recording? Unfortunately, I checked into this today and Zoom doesn't really support that. So not really possible, unfortunately. If you have some questions later or want to know more about it, please also just discuss them in the LCA user group with each other. Tatiana asked if we will be introduced to machine readable EPDs. I don't think so, but basically the data we integrate, some of them are machine readable, so we can integrate them automatically. But I can see that Vesco, our data team manager, is typing an answer, so perhaps he has a better option there. And I can see the other two are already being answered. Then a last question here from Taha. In case we pass the exam, in which way or format will we get the certificate of successfully completing the summer school course? You get a certificate that has your name on it, which is based on the email address you have signed up to. So basically, I can see you have signed up to the summer school. I can see you have passed the exam. And if those match up, you'll get your certificate. There's one and more anonymous question. If we input the materials in the toolbars, all the physical materials for construction, from small things to largest like concrete, steel, is it possible to enumerate social lifecycle assessment for the building through Click LCA? I'm not 100% sure what you mean here, but I think Vesco or Veseline will be able to answer that one for you. So thank you everybody for joining today. So this was the introduction to Click LCA, where we just discussed how you can do everything on our platform. There will be more introductions to Click LCA specifically about, for example, optimization. I'll go through some examples of how you can actually do an assessment, but definitely already familiarized with it today. There's one more question here from Yazid. Is a certificate like an AP certificate? No, it is not. So a lead AP certificate is very different. This is more to give you an understanding of how to do building LCA and carbon studies, specifically with our software. One more question, the social cost of carbon, is it the same as carbon tax? No, it's not exactly the same. It's a value which a company can set on their cost of carbon. If you're on the Help Center, just search for social cost of carbon and there will be an article that answers that question also. Noted on the feedback there. Alrighty, thank you so much for joining. I will see you guys tomorrow when we talk a bit more about the software itself. Please try to access the software a bit and play around and see the features and whatnot. So thank you very much for your time and see you tomorrow.